Hi, thanks for sending your question. So it looks like in your question, we're looking at how fast the radius is changing, which means we're looking for dr dt, and in specific, they want dr dt when the volume is 36 pi inches cubed. Let's look at what they're giving us. They tell us that the snowball is melting at a rate of 8 inches cubed per minute. So in math, that translates to the fact that dv dt is negative 8 inches cubed per minute because it's melting. They've also given us the volume at the specific time that we're looking at. So let's work on step 1 of this problem, which is we're going to differentiate both sides of the volume equation. You'll notice I've noted that these are functions of t, so we can remember that when we're differentiating. Differentiating v of t, we're just going to have dv dt on the left-hand side. 4/3 pi is just a constant, so we can tack that on front. And since r of t is a function of t, but we have this cubed on the outside too, we're going to use the chain rule. So using our exponent rule, we can bring the exponent down and reduce it by 1. So we're going to have 3r squared, multiplying that by the derivative of the inside, and the derivative of dr dt, or the derivative of r of t is just dr dt. So we can start with step 2 now. We're going to solve for all of our variables except dr dt. It looks like we already have a number for dv dt, so we're good there. 4/3 pi is just a constant. And, r squared. We don't have anything for r yet, but what we do have is the volume at the time that we're concerned with, and we have a formula for volume, so we can solve for r. I've done that for you down here. You're just going to go ahead and plug in the volume into the volume formula. And then you're going to solve for r. I've just multiplied both sides by 3/4, divided by pi, and taken a cubed root to yield r is equal to 3 inches. So let's go ahead and simplify and plug everything in. We can cancel these out here. And dv dt is equal to negative 8 inches cubed per minute. So let's go ahead and plug that in. And we're going to get 4 pi. R was 3 inches, so we're going to have 9 inches squared inside of r squared here. And of course, dr dt we can't fill in because that's what we're actually looking for. So let's go ahead and simplify. We still have negative 8 inches cubed per minute on the left-hand side. And simplifying the right-hand side, I'm going to get 36 pi inches squared times dr dt. Let's go ahead and divide both sides by 36 pi inches squared. And when you do that, you'll get negative 2 over 9 pi inches per minute. And that's your solution for dr dt. A decimal approximation for that would be approximately 0.07 inches per minute. Thanks so much for your question, and I look forward to answering more of your questions using SnapMath in the future.